Hello, chicken voice. Jerry, can you hear me?
Yes, we can hear you.
Okay. Hello, everybody. This is Ahmed Fouad. I'll be talking today about F#. I know this is the second visit for F#. Last time I tried to put as much demos as I could, but it didn't work very well. So today I'll try to make it as simple as possible. And let's hope we can continue on this topic and link it to my other topics in our offline events, which is XNA, and hopefully Connect. Also, you can work with F# on Windows Mobile, so I hope it will be interesting and we can continue adding more knowledge. So, let's start. So, we will talk about functional programming. So, I have a nice definition here, although it's a little bit rigid in Wikipedia, saying functional programming is a programming paradigm that treats computation as the evaluation of mathematical functions and avoid state and mutable data. The very important concept is that we avoid state and mutable data. This is in view of functional programming. But we are using today F#. F# has two parts, the F and the sharp. So it's combining two worlds, the functional programming paradigm and the .NET object-oriented paradigm. So it's concentrating on what rather than how. So you'll get this sense once we start typing F# commands. The idea is I don't care how it's done. I care more about what's the data, what's coming out of it. Okay. And normally in functional programming we use mutable values rather than variables. So usually in C# or in other object-oriented language we use variables. But here we use the term values because it's immutable, meaning it doesn't change over time. It's protected. So it's like a constant data always. Like if we assign a value, say A, it will always have the same value across your entire life cycle. In .NET we have mutable types, which we call variables, that can change over the course of your program. Also, to compare functional programming to non-functional programming, we have the declarative versus imperative. Okay, there is some spirit of functional programming in modern language like C#, especially in latest versions, that we have a declarative development. Like if we have using XAML, using LINQ. This is, this has the merit of functional programming. We'll see this in a minute. So, F#, little history, they spent around 5 years in Microsoft Research Center developing a functional programming language. It made it as a community preview, then it was released with F#2 in 2010 in Visual Studio. It had some roots of some influence from Haskell and OCaml, which are very well-known functional programming languages. So it has two parts, the F and sharp. So F for functional and the sharp for .NET object-oriented. It's first-class .NET language, meaning it can access any .NET library, and You can build libraries that can be accessed with your other .NET languages like C#. If you build ASP.NET with C#, you can access F# DLLs. It has the best of two worlds. This is what I think, okay? And it's a little bit different. So I'm hearing saying X doesn't equal X plus 1. It's a little bit different. We'll see this in a minute. In the F# way, usually, you start by specifying your mind, you prototype. This is one of the, little moments when we can start by prototyping and then change this to a production application. So you can build your solution up bit by bit, prototyping, testing, trying, and then have this linked together to build a real application. And we have the F# Interactive. F# Interactive is like an interpreter for F#, where you can directly write your code and execute it immediately, which is not really available to other .NET languages, and it's very, very powerful feature. We will be doing a lot of F# Interactive scripting. Last time we prepared all these demos, but it was too much, so I will do it a little bit by bit, and let's see what we can accomplish with the demos. Okay, enough slides. Let's start by building the Hello World application. As usual, I want to build a Hello World application, so let's do first C# and compare it, just like an entry for you. We'll have a Visual C# console application, and create it if I want to make just a console application of the Hello World. All I have to do is, let's get rid of some noise we don't need, we only need system. And say console.writeLine, Hello World, and wait for some entry, so just to make sure that it will not go away directly after running the application. That's it. This is the Hello World, simple, very simple Hello World console application, C#. Let's run it. That's it. Waiting for any key to be pressed, and enter, and it will close. So let's do the same in F#. Yeah, I have some key prepared stuff. Rather than having a using statement, I will have open. Okay, and surprisingly, I will start doing stuff directly without having a main function, all this parentheses and what we call noise in the C# application. I'll just say console. I have IntelliSense, which is very powerful in F#. And no semicolon. You can have hit Control J for code completion. Okay, and that's it. Let's run. We'll have the same results. Once I hit enter, it will close. So, just to compare the two applications, this is just 3 lines of code, and I can make it 2 lines of code actually if I just make like this. So system.console.application. It will be only 2 lines, but let's keep it like this to just compare. And here in the C#, I have to declare the class for the program, and then I have the main, I have this parenthesis, I have semicolons. This is not necessary in F#. And here, indentation is quite optional. Now, F#, I use indentation as blocks. So having a good writing skills is not an option of C#. Okay. So here in C#, I can do this, and it will work just fine. Okay. In F#, rather than having this starting and ending parentheses, we use indentation, tabs or spaces, depending. Okay. So this was a very simple Hello World application. You can notice immediately that the code is concise, small, just focusing on what, not how to do it. Okay? And we have the F# interactive. Starting from now, I will not do any application. I will not run an application. I'll just execute my code immediately in the F# interactive. So in order to get the F# interactive, in case you don't have it, just go to View, Other Windows, and you have F# interactive. Control-Alt-F. Okay? So, we spoke that we have values rather than variables. How to define values? We'll try this. Define something like this. Let x equal something like 12. So, we have a value called x holding 12 and through the entire course of my application, life cycle. I cannot just come and say, make it 24 values. Okay? If you come here, say the expression should have a unit, but it has type bool. Surprisingly, the equal sign is not for assignment here, it's comparison. So this will result in a bool value, which is false now. Okay? Another thing, it's called functional programming, so we have to define functions. Let's define a simple function, like square. So I'm defining a function called square that will take single parameter and will just square it. So here I don't have to do the parentheses. The intelligence is very, very powerful here. Just when I stop on top of the square, it says that a square that takes an int and returns an int. Okay? You see here, int goes to an int. By default, it's saying int. But if I come here, let my square value equal square of, let's say 1.5. Okay. If you come here, change it immediately. It's saying float goes to float. So the IntelliSense or the pre-compilation, it will scan your entire application file and detect the appropriate type. Okay, but don't be mistaken, it's strongly typed. So X has to be a float. Okay, but you don't have to define it. You don't have to say that it takes a float and returns a float. It detects it automatically. Sometimes when you get stuck, you have to define it. We'll see later on how to do it. Okay, so here I defined a value and I've defined a function. Okay, let's have another function, say sum that takes x and y, well, x plus y. Okay, this will have two parameters. Here, how it's expressed, it's saying int going into int, then int. So the last one is the result. The first two is the parameters. Okay. Of course, here we can do some sort of simple documentation. We can have XML documentation here, by the way. But I say just type just a sum function. Come here, you'll find saying just some function. Okay? Just having, rather than 2 for the comments, I have 3 slashes. Okay. Other types that we can define in this language. Okay, let's execute this first. All I have to do is just highlight the code, right-click, send to interactive, or simply hit Alt-Enter. Okay, it will be sent here to the interactive and say that value x, which is integer, is equal to 12. Okay, just remove this and execute this one. Send back because it doesn't find any necessity to have a float definition, so it fallbacks to integer, and I defined here the square function. So let's press something where equal 5 and enter. Say now the value MySQL is an integer holding a value of 25. So I'm executing my code without hitting the run button and the debug and breakpoints. I'm just executing my code. Okay. Another type that we have is called the tuple. Tuple is a sort of simple record. Okay. Let's do a tuple. I will discuss first the types that we have available, not all the types, of course, but some simple types, and we will progress, seeing how to use them. Okay. Let's tuple A equal 1 and 2. So I have this tuple, which it's written here. It's just running. Okay. Tuple A that have integer and integer. The tuple is separated by the star. Okay. It can be 3, not only 2. But let's keep it simple here. This is the tuple. And let's define another function. A very interesting feature you'll see right now, how easy functional programming can manipulate data. Let's define a function that works on tuples. It's called swap. I just need to swap the 2 values. Okay. I'll just say A, B equal B, A. That's simple. So swap will take a tuple that has 2 values, A and B, and will return another tuple with the value swapped. Pretty simple. Let's implement it. Let's swap tuple equal swap tuple A. Let's run all this code. So, tuple A is an integer, holding the value 1, 2, and they have a functional swap that will take tuple of undefined types. So, because there is no any arithmetic action here, this can be string, this can be float, decimal, whatever, and it will just return the tuple swapping the values. Okay? And this is an example that have a swap tuple value holding 2, 1. If you want to do this in imperative language like C#, okay, it's going to take a lot more than this. Let's define another function just to explore how easy it is to work with functional programming. Let's say round. I will just swap some values, but it's more than 2 values. Round. Take A, B, C, D. I will just I'll make it, let's make it reverse. Simple, I'll say D, comma, C, comma, B, comma, A. So it will take a tuple of 4 values, regardless of the type. It will just reverse it. Okay? Reverse of 1, comma, Ahmed, 20, comma, let's say, so I have the ref val that will take string int, and it will reverse it. Let's see what will happen. Let's first define function. And it's coming hi 20 Ahmed 1. Okay, so this is very easy. In 2 lines of code, I've done something that I could have written in 8 or 10 lines of code using C#. Okay, and I can make arithmetic operations on the tuples, whatever you want. So let's move on to something called records. To define a new type, record is a type, okay? First define type, something like card, okay? Here we will have to define the exact type of each parameter. So string, okay, from another string, and say, okay, this is copied from the examples, by the way, as bool. So I have defined a type called card that have 3 values: name, phone, okay, name and value are name and phone are a string, okay is a pool. Let's record A equal. This is going to be very interesting. Okay. Let's say it's 96, 555, like this. And okay, equal false. So I have defined record A, but I didn't say that record A complies with cards. Okay, I just defined the type first, and then defined the record. If you come here, it says that the value record A is of type card. Okay, the pre-compiler detected that this record A complies with this definition, and it's taking the record. Okay, so we have a record A. Okay. Something gone wrong. So I have this type and the value of type card, have the name, phone, and some Boolean value. Let's find another card, but this time I want to define a card for Ahmed with the same name, but different phone and different OK value. So rather than having to just type record E equal, okay. Here, I will not retype name equal Ahmed. It's the same name. So simply, I'll say it's of card. I'll take card A with phone equal what is it? Just copy and paste. So Here I'm taking the value of card A, okay, as my default data, taking the default data and changing only the phone and the value of, okay, let's make it true. And here, let's make it on 0, something like this. Okay, so it's called. Okay, so this is very interesting feature. It's used a lot across F#, but we'll go step by step with it. So I have now record A and record B, both are cards, named the same, different phone and different value for OK. Tamam? Okay. Let's define a function that will take C to just return a string. Let's see the name. I'll take all the parameters and composite them and bring a string back that Ahmed have this phone and the OK is checked or not checked. Okay? So, first time I had C dot, didn't recognize what C is, but once I define the name, next time it's giving me all the options, name, OK, phone, because it detected automatically that it's of type card. Let's have a condition, introduce other features of the language. If not, C dot OK, say, then of some value, mark or something. Okay, else nothing, just empty. This will be evaluated, saying if not, this is the not operator, just saying not. C dot K then return this string, otherwise return the empty string. See what will happen. So I've defined my function. Let's use it. We'll take record A. So here, automatically detected that card val A, it's a string and equal to Ahmed phone, this, and it's unmarked because it's false. Let's do the same for the next record. Let's record B and have it. Let's see what will happen. Okay, so it's evaluated the Boolean, and here it was also saying unmarked. Here it's empty. It's an empty string. So this is what we call records. It's very easy to use. It's very fun to play with, but not like the next one, which is called the lists. So lists is, you can think of it as immutable arrays, the arrays that cannot be changed. Okay, so list is following all our scheme of immutable values, but you can play with them. Very nice. F# have a lot of functionality related to lists. So let's define a list 1 to 10, which hold numbers from 1 to 10. Simply I'll say 1, 2, 10. That's it. So I define the list. If you come here, it's int list, okay? And if you go here, you'll find it's implementing collections, comparable, okay, enumerable, so you can enumerate them, you can do whatever you want, like the link lists, but it's a little bit different from the generic list defined in C#, which you can use here actually. But this is immutable, cannot change. The value is one set. Let's say I want to define another one from 0 to 10, which is actually the first one. Okay, the first one, but adding a 0 here, leaving 0. So I will use something called the cons operator. Something like this. Okay, I hope you can see this. So, something. This is better. Okay. So I have a list that holds values from 1 to 10 inclusive. So it's 11 values. Here I'm adding zeros in front of it. So this one will evaluate to 1, 2, 3, 4 till 10, and this one will be 0, 1, 2 till 10. Okay? Or I can define it like this. Let's say 1, 2, 3 equals, I can specify the values separated by the semicolon. Okay. So let's play with them a little bit. What's beautiful about functional F# is you can do recursive functions. I don't know if you are happy with playing with recursive functions, but let's do one example of recursive function, and then we will skip it. It might be a little bit confusing. So in order to define a recursive function, I just have to type rec in front of it and continue normally. Okay, some list. And the body of the function, I have to ident. Just press tab. This will mean anything on this level of indentation is the body of the function. Let's add something very interesting here. I'll explain this later. This might look a little bit confusing, but it's very easy. Okay, this is our first recursive function done on a list. Simply here, if we go here, it will say that it's taking an integer list and returning a single integer. Okay? This is like a switch case in C#, but it's a little bit more advanced. What I'm saying here, match this list, okay, maybe it's like from 1, 2, 3, with, if it's empty, because actually lists here are linked lists. If you are aware about computer, if you study computer science or aware about linked lists, this is simply a linked list. So the last value will be an empty value. So I'm testing, is this the last value? Finished? Then I'll return 0. Okay? If not, I will separate them into head and tail. Meaning, this is the first value of this list, and this is the rest of components. So if I'm passing here 1, 2, 3, y will be 1, and ys will be 2, 3. Okay? So if this is the case, do the following, or return the following. Y, the first value, plus some list of the rest of values. So what will happen here if I pass 1, 2, 3, is the first cycle will be sum 1 plus 2, 3, okay? Second cycle will be sum. The previous summation is 1, still 1, okay? Plus 2, plus 3, and the last one, the last cycle will be 1 plus 2 plus 3 plus empty. So this will resolve in the last one into 0 and it will stop. It will not do any recursive calls. So let's check if it's working as expected. First we define this and let's run it. 1 equal some list of 1 to 10. So we are summing all the values from 1 to 10. Let's see what will happen. It's 55. You can validate it yourself. But this is very powerful, of course, but you can do it a little bit more easier. Let's check how. Let's define another function, which is called doSum. Okay. I don't know. Shall we do the more complex one first or the easier one first? Okay. We'll have doSum with an accumulator and a parameter, which will return accumulator plus a. So simply it will have 2 inputs and it will sum them. Okay? Let's see how to implement them. Sum 2. I hope this is not very complex or boring. I see people dropping now. Let sum 2 equal just a list dot fold. There is a fold function that will take a function and apply it to all the elements in the list and return a single value. So I'm saying, please fold, okay, the doSum is the function that I need to fold it, okay, and starting value for the accumulator, and 1, 2, 10. So here, the definition of list have a function called fold, which will apply this function on all the elements of this list with a starting accumulator 0. Let's see what will happen here. It's returned the same value, it's 55. Fold is a very powerful function. Okay. Or we can do it much more simpler, saying let's sum 3 equal. I need just to sum it. List sum. I have it already. I'm just demonstrating, but you can say simply let's sum 1 to 10. This will do the trick. Okay? Do this. Another way of writing this is using the pipelines, where I can say let sum 4 equal, which is the same line as before, 1 to 10 pipeline list sum Okay, this will produce exactly the same like this one, but rather than passing 1 to 10 as a parameter to the function, I'm using the pipeline to pass the results from the left side to as a parameter to the right side. Okay? This is very, high level data mention. Okay, but let's wrap it and have the interoperability with object oriented, which is very interesting feature. I'll say open system drawing. Let's just copy it here. For an example of Windows Forms, I can do Windows Forms from here and change the data of the Windows Forms immediately. Let's say this one. I am opening drawing and Windows Forms and defining a new form with this parameters, visible equals true, have a text, topmost, have a size. So let's just run this. So I immediately have a form. Let me define a button and add this button to the form. Oh, sorry, I'm adding an action first. I'm adding a click function, which is a lambda expression. This is how do we define lambda expressions? Just doing a message box to showing hi. Now I'll have to add it to the form. So imagine that you can test your application, C# application, okay, like this, adding components, adding forms interactively on the fly, and having some buttons doing stuff, testing your data live, step by step. This is very powerful. Let's try to add a data grid and add it to the form. So I have a data grid now. Let's make a simple data source and change column width. This, you can imagine how this will impact your prototyping and testing. Okay, this is just a simple thing about how to play with .NET framework, Windows Forms, or whatever you can access WF, regardless what you are using, but you can manipulate any .NET or access any .NET libraries from here and do it step by step without having to compile the entire application and run it. Just one more thing, I will tell you how to do a new class in F#. This class can be accessible from, in F#, yeah. This will be accessible from any other .NET language as a normal .NET class. Like saying, this is a class called person that have a first name, last name, and age. I'm defining an internal fields, but they are mutable. Mutable means they can change over time, so I can assign data to them. Okay, 3 mutable values without stating the integer or string internally. Okay, and here I'm overriding or adding a new constructor. So if I'm saying new person without defining any of these values, it will take this as the default constructor. I'm defining a member which will be the property accessible from the .NET world. Just saying that. First name with, this is how we define a property. I'm stating the getter and setter normally. But for mutable data, I don't use the equal sign. I use the left arrow sign to assign a value to it. So setter takes the v, it will be assigned to the internal field. This is normal, like just a different shapes of doing stuff. style, but strictly the same. I define classes in .NET. Okay, I even can have something like this, defining a member which have a getter, a read only, getter only, and checking an internal value against 18. So if the age is more than 18, it will be an adult. Also, I can override default, some default methods like toString. So whenever I'm accessing person.string, .toString, it will be the first name space last name. Okay, let's just test this. Do a quick test. Let my person equal new person with Jerry. Don't know his age, but I'm guessing. Okay. So I have a person, Jerry Yasser, and let's access. Let's is adult equal my person is adult. Okay, this will be a pool, saying pool true. Okay, let full name equal my person dot toString. So it will be Jerry, yes. Okay, that's a quick demo. I don't know if you guys are interested in this feature, but the most powerful one I see is either how to use F#, either to build your data manipulation algorithms inside, if you are doing any, inside the F#, especially when you can here access web services, fetch some data, manipulate them, convert them to lists, slice and dice with them, and encapsulate all of this in a DLL and use it in your project, C# project, ASP.NET project, whatever. Okay? This is one way to do stuff with F#. The other way is building prototypes, trying out stuff in your project, or ideas or algorithms or whatever, like what we are doing here with Windows Forms, creating a form, doing stuff step by step, testing out data. I can change any property on the fly, a single line, hitting Alt Enter. It will be changing in the form. This is very powerful. You can use it in test. I use it a lot in testing my applications. Okay, so I hope it was not too boring. I know it's boring, but it's not too boring. So let's wrap it up. For more resources, for more resources about this one, you can have F#.NET, which is holding all data you need about F#, especially with the new F# 3.0 that will be released with Visual Studio 2012. That have some interesting features. Hope to cover it soon. Okay, thank you. Jerry, are you there? Hello?